All right, excuse me. So start with a couple of announcements. Looking at the end of the school year. Next week is just your normal schedule. Group A, first, third, fifth, and seventh hours on Monday. Group A, second, fourth, fifth, and sixth hours on Tuesday. Wednesday will be the last day of the the flex days. So, and last official day of office hours. However, if you need help, reach out. I'm always happy to work with students. Um, and my afternoon schedule is pretty wide open. So if it's a day where you're not in class and you need help with something, let me know. I'm happy to work with you. And then Thursday will be cohort B, odd hours 1, 3, 5, 7. And Friday next week will be 2, 4, 5, and 6. Then we have the week. So the 31st is Memorial Day, no school. Tuesday will be odd hours, 1, 3, 5, 7, and it's an early release day. And will still be cohort A. Wednesday and Friday, cohort B will meet. And Thursday will be and those will be regular hours. And Thursday will be cohort A, regular hours. The last week of school is a little bit different. My understanding is that Monday the 7th is regular hours, 1, 3, 5, and 7, and that is for both cohorts, A and B. And then Tuesday is an adjusted schedule for early release. For 1, 3, 5, and 7. So odd hours, Monday and Tuesday, really weird, I know. And then Wednesday and Thursday that week will be odd hours or even hours, 2, 4, 5, and 6, regular schedule on Wednesday. And I thought I saved this. I guess I didn't. This should be hour 2, 4, 6, and 5. Early release on Thursday, the 10th. Questions about the schedule? I know it's odd. It will be in the notes when they're posted to Schoology. Should also be getting them in an email if you haven't already. All right, then equipment turn-in. If you have a school Chromebook, right now the times are set for June 9th from 8 to 11 a.m., June 10th from 1 to 4 p.m. So that's the Wednesday and Thursday that last week, and Friday, June 11th from 8 a.m. to 4 p.m. So some morning hours, some afternoon hours. If you are going to be taking classes this summer, you still need to turn in your Chromebook and then you will check it back out. And that's actually has to do with something, I think the insurance program that the district has on them. So it's not because the high school is being mean and wants to make you come in. It's the insurance company and the insurance on the Chromebooks. All right, so that's equipment turn-in. Questions there? If you think of some, feel free to share them in the chat. I will answer them the best I can. If you think of it and we're doing our Zoom or our breakout, you can ask them as well. All right. So we are starting our last chapter. This is the pink packet that we'll be working in. And we're going to talk about exponents and radical functions. So doing a little work with exponents today. Hopefully most of this should be review. And then as we move toward rational exponents and graphing and solving equations that have rational exponents. Remember, rational number just means it's a fraction. So we're talking about exponents that are fractions. All right. So the unit goal, simplify expressions involving rational exponents and radicals, and sketch the graphs of transformations of radical functions. I can also solve equations that contain radical expressions. Excuse me. All right. So just some review of some terminology. If we have 7 to the third power, the 3 is the exponent, the 7 is the base, and the whole thing is called a power expression. And that means you're taking 7 times itself 3 times. So if we had a squared, that would be a times a. B cubed would be b times b times b. C to the fourth, c times c times c times c. If it was d to the fifth, that would be d times d times d times d times d, and so on. Excuse me. So that's, and we call this part an expansion. This is the expansion of the power because we're showing the whole multiplication problem written out. All right. Write each of the following as a product. So 2 cubed, that's 2 times 2 times 2. 2 to the fourth would be 2 times 2 times 2 times 2. So if we multiply 2 to the third times 2 to the fourth, we're going to write it out first as a big product, and then we're going to write it as 2 to some power. So we have 2 cubed times 2 to the fourth So that is going to be 2 to the, let's see, let's count how many 2's we have here. 1, 2, 3, 4, 5, 6, 7. So that would be 2 to the 7th power. So what that means is if we are multiplying two things with the same base, we're going to keep that base and we're going to add the exponents. So the big thing, those bases have to be the same, and here their A's up in the example, they were 2's. Right. Excuse me. Simplify the following. 4 cubed times 4. Now remember, this is 4 to the first. So we have the same base, it's 4. Add our exponents, 4 to the fourth. That would be a great answer. Just leave it like that. Some people want to actually multiply it out. This multiplied out would be 256. I'll show you on the calculator how to do that in a moment. So we did 4 to the power of 3 plus 1 to get 4 to the fourth. Okay. Remember, parentheses means we're multiplying. So this is going to be y, the same base, and we're going to take 4 plus 5. All right. So here again, parentheses, so we're going to multiply. We have 4 times 2, because those are the coefficients. X squared times x to the third, so we're going to take 2 plus 3. Y cubed times y to the negative first, so we take 3 plus negative 1. 4 times 2 is 8. X to the fifth, y squared. Right. And in this case, I multiply the numbers together because they're just coefficients. Where here, I probably would leave my answer as 4 to the fourth power. Usually around the fourth or fifth power, we start just writing numbers out just because, I'm sorry, less than the fourth or fifth power, we would actually multiply. If it gets higher than the fourth or fifth power, writing it with the exponent is totally acceptable. All right, a couple for you to try. I'll give you about a minute. And then we can look at these solutions. All right, so here we have the same base. It's going to be 6. We take 4 plus negative 5 plus 2. Now let's see, that would be 6 to the positive first power. You don't need to write that power. That's the only one we don't have to write. So you could also just write it as 6. Second example, we take 5 times negative 2 And x, we have the same base for x's, so 2 plus 5. 5 times negative 2 is negative 10. 2 plus 5 is 7. Negative 10, x to the 7th. And again, I could, either of those answers would be correct. All right, again, hopefully review and you're all looking at this going, yeah, Mr. Gingrich, we know how to do that. That would be great. If we expand that idea, if we have a power raised to a power, so for instance, 3 squared to the 4th, well, that would be 3 squared times 3 squared times 3 squared times 3 squared. And then we could rewrite it as products of 3. So every 3 squared gets a 3 times 3. And I'm using parentheses around my 3 squareds. You don't have to put them there. But if I wanted to write it now as 3 to a single power, if I add up 1, 2, 3, 4, 5, 6, 7, 8. So a power to a power, we don't add the exponents. Now we are multiplying the exponents. So if I have a to the m power, and I take that whole thing to the nth power, I multiply those two exponents. You could also write it without the dot. It could be written as a to the mn. Totally acceptable. All right, so here we go. Couple that we'll do together, one that you'll do on your own. R to the 5th raised to the 6th, I multiply 5 and 6, I get R to the 30th. 6 squared raised to the 4th, I would get 6 to the 8th. Now, if you're one of those people who says, but I want to know what number that is, I'll show you here in just a second. If I share my calculator, 6 to the power of 8, that would be 1,679,616. Again, I kind of prefer the 6 to the 8th, but it would be just as correct to write that in numeric form. Go ahead and give the next one a try. I'll just hang out. I'm only going to give you about 30 seconds. All right, so 3 squared raised to the 6th. Multiply my exponents. I get 3 to the power of 12. All right. So now we're going to look at what happens if we have a product. We're multiplying two things together, and then we're raising it to a power. So 4 times 5 raised to the 3rd power, or 4 times 5 cubed. literally means we're taking 4 times 5 times 4 times 5 times 4 times 5. If we rearrange this so that the 4s are all together and the 5s are all together, which we can do because multiplication allows that, we get 4 times 4 times 4 times 5 times 5 times 5. So writing it with exponents, we'd have 4 cubed times 5 cubed. All right, and so that leads to a rule. The power of a product, we take each term that we're multiplying and raise it to the power. You can think of it almost as distributing the power. Okay, works over multiplication, does not work over addition or subtraction. All right, so if I have x cubed y to the 4th, that whole thing squared or raised to the 2nd power, that means I get x cubed squared y to the 4th squared. I apply the exponent, and I use my power to a power rule, which says multiply the exponents. And we get x to the 6th times x to the 8th. If we have a coefficient, that still gets raised to that power. So this is going to be 3 to the 4th n squared to the 4th. 3 to the 4th n to the 2 times 4th power. 3 to the 4th is 81 n to the 8th. And I should write equal signs. These are all equivalent. Right. Then if I take power to a power and I am multiplying things together, so now I have to use all of my rules. This 3 is not inside the parentheses, so it does not get affected by that power. But the x to the 4th is going to be cubed. Here, the -3 gets squared, and the x squared gets squared. So I have this 3, x multiply gives me to the 12th. -3 squared is 9. X squared squared would be x to the 4th. I can multiply my coefficients. That's 27. Add my exponents, 16. I don't know why I'm not using equal sign today, but I should. Those should be equal. All right, another one for you to try. All right, so power to a power. So we're going to take each term and raise it to the fourth power. So one of the interesting things, if we have a negative number to an even power, we're going to end up with something that's positive. But you can always just multiply it out. -2 times -2 times -2 times -2. That is positive 16. And here we're going to multiply our exponents. 3 times 4 is 12. 6 times 4 is 24. All right. Now we're going to divide. So write both the numerator and denominator as products, cancel out common factors to simplify. So 2 to the 5th, 2 times 2 times 2 times 2 times 2. 2 cubed, 2 times 2 times 2. I had that cubed in my mind. And when we're multiplying, if we have the same factor in the numerator and denominator, we can cross them out when we're multiplying. So this leaves us with 2 squared as our answer. So when we're dividing, if we have the same base, we're going to keep that base and take the power in the numerator minus the power in the denominator. And then again, we will reduce if we can. All right, so here we have the same base. So our answer is going to be 4 to the 5 minus 3, which is 4 squared. Again, I like that answer. You could write it as 16 because we can square 4 pretty easily. Excuse me. For the second one here, same base. We have x for the base. We're going to take the power in the numerator minus the power in the denominator. That denominator power is -2. Subtracting a negative is the same as adding a positive. We end up with x to the 7th. All right. So here, what I'm going to do is I'm going to look at this as kind of 2 separate problems. I'm going to look at 3 over 9 and x to the 4th over x squared. And you could use your calculator if you needed. The 3 over 9 cancels into 1/3. X to the 4th, x squared, so we can subtract our exponents. Either of these answers would be fine. The second one I like because we won't confuse where the x squared is. Where here, if it's written a little bit different, some people might say, well, is that 1 over 3x squared, or is it 1/3 times x squared, or how is that meant to be? So to eliminate a little bit of confusion, we can write it with the x squared in the numerator. All right, again, a few for you to try. All right. Again, 12 over 4. If we're not sure how to deal with that, we could go to our calculator. So anytime you have the numbers part, you could go 12. A fraction bar is just a fancy way of saying divided by 4. Enter. That one comes out exact. It's a whole number. It's 3, which is good. So the 12 divided by 4 gives me 3. I'm going to get a to the 4th minus 6, and b to the 3rd minus 1. So remember that. Without an exponent, we just understand that that's a 1. So this would be 3 a to the negative 2nd, b to the positive 2nd. And we'll talk a little bit more next week about negative exponents. For right now, we're going to leave it just like that. Another one with some coefficients. X to the 4 minus 3, y to the 1 minus negative 2. So again, I would just see if I can reduce 24 over 9. And if you're not sure, go ahead and use your calculator. 24 divided by 9. And you can go math and get it in a fraction if you wanted. It's 8 over 3. And the reason that's, if I just did 24 divided by 9, I get that decimal approximation. So if you did that, didn't do the fraction right away, you can just go right from there, go frac, enter, enter. So 8/3 is part of our answer. Four minus 3 is x. You could also put the first, the power there, a 1. You don't have to. 1 minus negative 2 is the same as 1 plus 2, so it's y to the 3rd. And as we said, we could write those variables in the numerator. These are both the same. All right, then what happens if we take a quotient, a fraction, and raise it to a power? Well, we know the 5th power means take this thing times itself 5 times. So 3/4 times 3/4 times 3/4 times 3/4 times 3/4, which is the same as 3 times 3 times 3 times 3 times 3 over 4 times 4 times 4 times 4 times 4, or 3 to the 5th over 4 to the 5th, which leads to like the last rule we're going to have today. Take a look at a couple different examples, but the last rule, if we have a fraction raised to a power or a quotient raised to a power, you take the numerator to that power and the denominator to that power. Notice here the bases are not the same, a little bit different than the previous example we looked at. Excuse me. So we apply the power again, that's an okay way to leave your answer. However, you could multiply it out, 125 over 343. Example B. I'm going to take everything to the fifth power. So 2 to the fifth, x to the fifth, divided by y to the fifth. 2 to the fifth is 32. X to the fifth, y to the fifth. Oh, now here we have a to the third over b squared, all raised to the fourth power. So we apply that fourth power. We would get a to the third raised to the fourth, b to the second raised to the fourth. Multiply our exponents, a to the 12th, b to the 8th. All right, and one for you to try. All right, apply that third power. Two cubed is 8. X squared raised to the third is x to the 6th. Y to the 4th raised to the third is y to the 12th. All right, so just a couple more examples where we have some simplification that we can do and then get our answer. So in this one, we can apply the fifth power. Two to the fifth, x squared to the fifth, x cubed to the fifth. 2 to the fifth is 32. X squared to the fifth is x to the 10th. X cubed to the fifth is x to the 15th. Subtract. Always numerator minus denominator. We would get 32x to the negative fifth. If you wanted on this one, another approach would be to simplify the fraction first. So you could take 2x to the power of 2 minus 3 raised to the fifth, which would be 2x to the negative first raised to the fifth, and now apply the power. Either way, many times simplifying first does make it a little bit easier. Here, maybe not so much. So we've got x squared y, and then we're going to take times x squared to the fourth, y cubed to the fourth, over x to the ninth, y to the sixth. So x squared y, x to the eighth, y to the 12th, over x to the ninth, y to the sixth. Adding my exponents for my x's, adding my exponents for my y's. Remember that y is like y to the first. Rewrite this a little bit because it's a little sloppy. That is a 6. And now I can subtract. So x to the 10 minus 9, y to the 13 minus 6. Boy, oh boy. I said x, but I wrote 10. I was getting ahead of myself, I think. 10 minus 9 is 1. 13 minus 6 is 7. All right, another one for you to try. All right. So this one, I would probably simplify this one first. X to the fourth minus 1. Uh, 4 minus 1 is 3. Remember, that's like y to the first. And now I can apply my exponent.
Pardon the interruption. The boys JV golf tournament has been canceled. Students stay in class. Again, the boys JV golf tournament has been canceled. Thank you.
Multiplying my exponents, I get x to the ninth, y to the third. All right. So if you have questions, you can certainly ask in the chat. I'll set that up, or in the breakout rooms. I'm sorry.